Building applications on top of models like ChatGPT, Gemini, or Claude is the hottest trend in software engineering right now. If you can call an API, you can build with AI. The problem, the AI bill can skyrocket, and the key to controlling it lies in understanding one unit, the token. In this video, we're going to answer 3 questions. What's the difference between a token and a word? Why AI models use tokens instead of words? And how can we use this knowledge to reduce costs and improve the efficiency of our applications? Let's discover it in the next few minutes. A common misconception is that large language models can understand words. They don't. Words are first broken into tokens, which are converted into numbers. That's a simplistic explanation. And why do they use numbers? Because neural networks are mathematical engines, so they need to perform calculations on those numbers. They can't do it on text. Now, for instance, the token cat might be mapped to the number 5252 and dog to 3686, while longer words are split into more tokens. For example, in GPT-4o, the word beautifully is split into 2 tokens, beautiful and ly. Misconception becomes 3 tokens, misconception. Why is that? There are 3 key architectural reasons. The first is that tokens are meaningful components. By breaking words into parts, the model learns their individual meanings. For example, it learns that the token miss often negates a word by repeatedly seeing it in pairs like misconception, misunderstanding, or misalignment. And this allows the model to grasp the meaning of complex words just by combining the known parts, which are the tokens. The second reason is vocabulary efficiency. Tokens drastically reduce the vocabulary size the model needs to understand. A word-based vocabulary would have millions of entries, especially if you consider all the tenses, the plurals, the slang words, and the new words that gets created every year. In contrast, a token-based vocabulary has a smaller, predetermined, fixed size. Usually for modern models, we're talking about 100,000 tokens. As a result, we can pack much more information into the model's context window, which is a bit like its short memory that it's used to process our prompts. And finally, tokens help us handling the unknown. What happens with a typo like running with 3 ends, or a new word like deplatforming or ChatGPT? Our base system would fail, marking it as unknown. A token-based system gracefully handles it by breaking it down into smaller parts, like running or deplatforming, allowing the model to make highly educated guess about its meaning. Now, for the most important part, how do we use this knowledge to our advantage? First, we optimize our data payloads. The data format we use to communicate with the LLM has a massive impact on our costs. So let's look at the exact same information presented in 4 different formats. The XML version, as we can see, costs 57 tokens. JSON is better at 40, and YAML improves it to 25. But the simple CVS format is the most efficient at just 19 tokens. If you think about it, that's a 66% cost reduction. So if we were spending 10,000 a month on ChatGPT, we would be spending 3,300 instead. So suddenly, the CSV format looks very appealing. Second, we can engineer our input prompts. In this case, the trick is to be direct. Don't be conversational. Instead of saying, "Could you please summarize this document?" just say, "Summarize this." Save the pleasantries. The AI isn't sentimental, but it makes you pay for each word. So, fewer tokens, same result, less cost. Third, we also need to control the format used by the LLM to answer our prompts. Repeating format instructions in every single prompt would be wasteful. A more professional and token-efficient approach is to use system prompts. A system prompt is a meta-instruction that you send once at the beginning of the session, and that would apply for all subsequent user prompts. For example, we can set a system prompt that says, "You're a helpful assistant that only responds in valid CSV. Don't include any additional text." This saves tokens on every call and gives you a predictable, machine-readable output. Fourth, it can help us understand how to chunk large document. When we process a document that is too large to fit in the context window, our first challenge is to avoid token-level fragmentation. Naive methods like splitting by character count can cut a word literally in half, sending a nonsensical fragment like miscon to the model. This is guaranteed to degrade the quality of the response. The baseline solution here could be to use a library like OpenAI token that converts the text to tokens, and then we could split the document by token number rather than character number. But even if this approach would avoid us to break a token in the middle, it doesn't still prevent semantic fragmentation. Ideally, we don't want to split a sentence or a paragraph right down in the middle. There are techniques to solve this problem, but they are very complex, so we might deal with them in another video if you wish. If you want, write me a comment. So let's recap what we learned today. First, the vocabulary of an AI model is made of tokens, not words. And tokens are more meaningful and flexible than words. They are like Lego bricks that they can be combined to infer the meaning of unknown or misspelled words. They also allow us to express more complex concepts within the limited context window space. Finally, we can use tokens to engineer our data and prompts, which means we're cutting costs and improving performance. If you like the video, help me out by liking, subscribing, enabling notification and sharing the video with your friends so that everyone can learn something new. See you next time.